Okay, so this slide describes what I just discussed. So if propensity is greater than or equal to cutoff probability, classify as 1, otherwise 0. So default cutoff probability is 0.5. Now here, one thing that we need to notice is the greater the value of the cutoff probability, the less likely it is that we predict class equal to 1. Okay, so if the cutoff probability is a 0.9, for example, so not very many observations will go above that very high threshold or cutoff point. Okay, so if it is equal to, if it is closer to 0, okay, so then more, it's easier. It's a lot more observations will cross that hurdle cutoff point, and more observations will be classified as 1. So let's look at the extreme case. If the cutoff point is set at 1, so that means no observation is going to be classified as an event. All predictions will be class equal to 0. And the reverse is the case. If you take the other extreme and if you set the cutoff probability at 0, then all predictions will be class equal to 1. Alright, so given these classifications, then we can set up what is called classification matrix. And this matrix is also known as classification confusion matrix. Confusion here being we getting confused, the model getting confused in terms of which class a particular observation should be classified into. So suppose if the actual classes are C1 and C2. Okay. Now the model will predict of the C1s, maybe most of it, if the model is any good, most of those will be predicted as C1. But there may be some which may get predicted as C2. So these are the erroneous predictions. So let's call if C1 is the actual class, and then we have this notation n subscript 1 comma 1. First subscript is row, the second subscript is column. So this is the number of all the actual C1s. N sub 1 comma 1 gets predicted as C1. N sub 1 comma 2 gets predicted as C2. And for all the C2, actual C2s, N sub 2 comma 1 gets predicted as C1, and N sub 2 comma 2 get predicted as C2. Okay. So given this general framework, we can come up with some accuracy measures. Okay. First, let's look at an example of this. Okay. Suppose we have our riding mower example. So here are the two predictors, okay, income and lot size, and then the ownership of riding lawn mower. Okay. Now let's assume that we did a model, and these are the probabilities that we got from the model, propensities. Okay. Now if we use the cutoff of default cutoff of 0.5, 13 of these records will get classified as 1. But if we set the cutoff at 0.8, okay, only 7 will cross that threshold. Okay. But let's use 0.5, and then we can classify these. Then what happens is, of the 12 owners, okay, if you count here, there are 12 owners. Of the 12 owners, 11 will get predicted as owner, but 1 will get predicted as non-owner. Okay, there is a typo here. Okay. Now, of the 12 non-owners, 10 will get predicted as non-owner, and 2 will get predicted owner. So there are 13 predictions of owner and 11 predictions of non-owner. Now, based on this confusion matrix, once we have constructed that, then we can compute all of these different measures of accuracy, misclassification rate, accuracy rate. Then we have a couple of events, couple of measures called sensitivity and specificity. and then false positive rate and false negative rate. So let's examine these one by one.